Now let's look at another method for solving simultaneous linear equation, and this is the substitution method. Now again, substitution method is very simple when we have two equations in two unknowns. So here are two equations in x and y, and as the name itself suggests, the substitution method, the way it works is that we use one of the equations to find the value of x or y, and then use that value and substitute in the second equation. So let's just do it and see how it works. So here we have 3y, and here also we have 3y. So what we'll do is that we'll say 3y from this equation, from the second equation. I'm saying that 3y is equal to 2 minus 3x. I can say that, right? Because I took the 3x to the other side and I got 3y is equal to 2 minus 3x. So that is, I now expressed y in terms of x using the second equation. Now I substitute this value of 3y right here. So that is the substitution method, substitution. Okay, that is what it is. Okay, so what do? I write it, 2x comes as is. So this is the first equation now I am writing after doing the substitution. So 2x remains 2x, and this 3y actually becomes, plus this 3y actually becomes 2 minus 3x and is equal to 5. Very simple. Now this 2x minus 3x becomes minus x, plus this 2 remains a 2 is equal to 5. If we solve this, this becomes x is equal to, will be equal to, minus x will be equal to 3, which means x is equal to minus 3. Okay, so this was the substitution method. So we were able to find the value of x as minus 3. Now what we can do, we can now substitute the value of x. Okay, so now that is the last step. We now of course have to find the value of y. So we already know y in terms of x. What does it mean? So this is 3y. This is equal to 2 minus, of course, 3 into minus 3. So this becomes 2, minus become plus 9, and this is equal to 11. So 3y is equal to 11, which implies that y is equal to 11 upon 3. Okay, very simple. So we were able to find both the values of x and y. Again, our substitution method is also very simple, and the substitution method we will use only when simple substitutions are possible. So for example, here we were simply able to substitute 3y for 3y. In that case, we will just use substitution method. If it becomes complicated, when we are having fractions, when we do the substitution and we have to have fractions. So for example, if the first equation really were, okay, if the first equation was 2x plus y is equal to 5, in that case we would have y as, we would have fractions here. So y would come out to be 2 by 3 minus, so this will be divided by 3. Okay, so y will be equal to 2 by 3 minus x. Now we have to deal with fractions. In that case, we would not really prefer the substitution method, but we will prefer the elimination method. So now let's look at the second example. Here also what we have 2y here and we have 2y here. So we can substitute the value of 2y from here in terms of x from here into the first equation. We can directly do that, but just let's substitute the value of x and see what happens. Okay, so from the second equation, I find the x in terms of y. So x will be equal to 2 minus 2y. From the first equation, I have 3x plus 2y. Notice that there are no fractions here. So I'm still good for doing the substitution. So now I substitute this value of x in the first equation. So there I go. So this becomes 3 into 2 minus 2y plus 2y is equal to 10. Now this becomes 6 minus 6y plus 2y is equal to 10. This becomes 6 will go to the other side, and this and minus 6y plus 2y will become minus 4y, and this 6 will go to other side and this will become 4, or y will be equal to minus 1. Now we can substitute this value of y equal to minus 1 here. Okay, so let's just do that. So from here we will say x will be equal to 2 minus 2 into minus 1. So this minus become plus. So this becomes 2 plus 2, which is equal to 4. Again, not very complicated, very simple. Substitution turned out to be simple in this case, because again notice that there were no fractions here. If there were fractions here, we would not prefer this method. Of course, if you have been asked to use specifically substitution, then you don't really have a choice, but otherwise we would not prefer if there were fractions. So again here, let us just see and try to substitute y y from the second equation into the first equation. Let's just try to do that. Let's see what happens. So this becomes 2x minus, I'm writing the second equation again, okay, and then this means that minus 3y is equal to 11 minus 2x, and this means that y is equal to minus 11 by 3 plus 2 by 3x. Now this is not preferred method. Now we are not going to use substitution in this case, okay. You should be able to identify these cases straight away. We are not going to use at least this particular substitution in this case because it becomes complicated. Y is coming out to be in terms of x as fractions, and that becomes very untenable. It might become untenable. So what we'll do instead, we'll try to see if there is any other substitution available. So this is 2x is here and 2x also appears here. So what we'll do is that we'll find out the value of 2x in terms of y. So from this equation we can write 2x is equal to 11 plus 3y. Now this 11 plus 3y can go right here, it can go right here. Okay, so this becomes 11 plus 3y plus 4y is equal to 32. So this becomes 7y. And this will be equal to 32 minus 11, which is equal to 21, or y would come out to be equal to 3. Now we know the value of y, substitute in the value of in this equation that we have here, and then we get, this implies that 2x is equal to 11 plus 3 into 3, which is equal to 9. So this becomes equal to 20, or x will be equal to 10. Okay. So substitution, what we are trying to substitute becomes very important. If you have fractions, leave it. If no substitutions can be made, then go back to elimination, and then that is our that would become, of course, our preferred method in all the cases. Okay, thank you very much.